to film himself. All right, now we have some evaluators for someone. That would be Vicky and Tom, who would write a written evaluation, and Martin and Teresa. And the two question people would be Travis and Chandler. You would be our question person.
Okay, my presentation is going to be about prime numbers, and I'm going to prove the claim that there are infinite prime numbers. So let's start with the definition of a prime number, which is that it is a number which has two divisors, one and itself. And the set of prime numbers is okay. So what is the best way to find if a number is a prime or not? So if I have any number n, what not the best, what's the easiest way to find if it's a prime or not? Any ideas?
Once again, the question.
If I have a number n, what is the easiest way to find if it's a prime or not?
Whether it is prime or not.
Divide all. Try to divide this number by all numbers less than this number.
Okay, first method is that check n. Okay, can we improve on this? Is there a better method? We don't have to divide by.
Check any number. Check any prime number less than n whether it divides this number.
Okay, that's a better method. Check if any prime number less than n is its divisor. And this is it clear to everyone that this will work? Because, and I mean I can explain this because if a number is not prime, it means that it has prime divisors, right? So if I have a number, suppose 6, no, maybe 18. 18 is divisible by 3 and 6, and 6 is then in turn divisible by 2 and 3. So basically the chain just goes on until you hit prime numbers. So if I can divide the number by prime numbers, then I basically use 6 as well. Does that make sense? So this is the better. You can even improve on this because by checking for numbers less than under root n, less than or equal to under root n. That's it. So now I'm going to prove that there are infinite prime numbers, and I'm going to use a proof by contradiction, which basically means that I'm going to first assume that the statement is false, that there are a finite number of prime numbers, and then I'm going to say that the assumption is wrong. So because this is wrong, there must be a finite number of prime numbers. So suppose we have n prime numbers. And now what I'm going to do is that I'm going to find another number n, which is basically a multiple of all of these. And I add 1 to that number. So now this new number is not divisible by any of these n numbers, and so it's not divisible, it has to be a prime number. And this proves that I can find a new prime number, hence the assumption was wrong, and there are infinite prime numbers. Does anyone have any questions?
At last, why did you add 1 and not any other number?
If I cannot add any other number because 1 is not a prime number. So if I add 2, basically this is all divisible by 2, and if I add another 2 at the end, this will be divisible by 2. If I add 3 at the end, this is all divisible by 3, and adding 3 means that the new number is also going to be divisible by 3. Any other questions? Yeah.
If I have a very large value, so how
Very
can I check it very quickly? Is it a prime number or not?
The quickest way to do it is to calculate all the prime numbers which are less than or equal to under root n. Suppose your number is n, so you find all the prime numbers which are less than or equal to under root n, and if any of those numbers is a divisor of that number, then it's not a prime number, otherwise it is. Does that make sense?
Yes. Actually, my question is that if the
If the number is really, really
very,
large.
very large, so how can the computer do that?
I mean, you need to compute.
Only computer.
Yeah.
So if I have 1,111 or 1,001, so
1,000.
you have to check.
Yeah. There are ways to do that actually. I mean, SETI at home I think has, not SETI at home, but they have these cloud computing things where they do find very, very huge numbers. The biggest, largest prime number is, I think if you start writing it, it's going to take the entire board. That's how large the number will be. Any other questions?
Can we, complete the construction of prime numbers that way? For example, you have the n+1 prime number, but multiply those prime numbers together, n+1.
You could, if this was the n+1 prime number, but
Yes.
as it turns out, it isn't.
Really?
Yeah. The simple way to do this is, suppose if you have only 2 and 3, and you multiply 2 and 3 is 6, and you get the 7th prime. So you don't get, if you got the n+1 prime number, then you could just keep on going. That would be easy to get. Okay, any questions? No? Yeah.
Sorry, I'm not so good at math, but I want to ask the basic question is, what is the importance of prime number in daily life?
Not much.
Yeah, because in high school, in elementary school, we learn about prime number, and it always confused me. What is that used for?
I don't think it's very useful. I know it's useful in cryptography, but apart from that, I don't think there are many uses. Does anyone know?
Say
Uses
you
of
want
prime
to send a mail to your friend. You use Gmail or any other mail service, right? They encrypt the message in a unreadable format. For those things, they use prime numbers to encrypt.
Yeah, encryption is, I think, the only use of prime numbers. Thank you.